Hey JEE aspirants, I'm Tarush Rajput and back with another video. Today we'll be discussing the concept of virtual work. Uh, in work power and energy, you must have studied this concept already, but like we'll be studying a little more advanced problems on that, and we'll also study whatever you have studied for JEE also. First of all, I want to say one thing that questions related to this concept have not been asked in JEE. I searched a lot, I didn't find any. But if you are like you have completed the syllabus for mains and advanced, and you are like you want to study some more concepts which are not too far from JEE point of view and can help you in JEE Advanced, you can study this. There is no problem in that because the topic is not too high level. So you can just go through it. It will help you, that I can guarantee. So it was discovered by a Swiss mathematician, Jean Bernoulli in the 18th century. That is not needed for like the application. We just need to study the application. The application is basically helpful in questions of static equilibrium. As we know, equilibrium is of two types. Equilibrium. Basically, equilibrium is of three types. So, but here we are discussing only static equilibrium conditions. Um, it is it is an alternative approach. So you can solve the questions where you have to, for example, alternative approach for finding forces. For example, some questions are like this, like a block is kept, and we'll discuss a question similar to this also. And a force is being applied, then find the friction, and this is fixed here. So basically, simple NLM question, but you can also use this approach, and this approach might be helpful in some cases where NLM will be quite lengthy. So this is just an alternative. So uh, of course, rigid bodies must be in equilibrium. We are not talking about non-rigid as far as JEE is concerned. Um, just let's consider a particle at point A, and a number of forces are being applied on the particle. F1, F2, F3, F4. Uh, if the resultant of all the forces moves the particle by a distance, that let's say R is the resultant, moves the particle from A to B, and the displacement, let's say it will be dr, let's say. So the work done will be R vector dot dr vector. Simple dw. No, let's say W only because the force is resultant. So that's the network done. Or we can say F1 vector plus F2 vector plus F3 vector plus all the forces into dr vector dot dr vector equal to W vector, network done. And this is basically summation of F1 dot dr vector gives us the network done. So uh, in case of equilibrium, in case of equilibrium, we know that dr vector must be zero. Why? Because the particle is not moving. Of course, simple thing that from A to B, the particle won't move. We are just considering. So virtual work says that we are moving, we are, let's say in a better term, displacing the object virtually. That means the object is in equilibrium, but for the sake of solving the question, we are considering that the object is moving a little bit. For example, this object is in equilibrium under a lot of forces. Let's say friction, normal and mg will cancel out, so no displacement in the y direction. Let's say another force P has been applied, and some value is not given. So you can just consider that this particle has been displaced by a distance of dx, and then you can apply the concept of virtual work that says that if the particle has not moved, then the net work done must be zero, which means the work done by all forces must be zero, which means P dot dx plus, let's say, the frictional force dot dx equals to zero. Actually, we don't need to consider the sign of the forces because we are already doing dot product right now. So it will automatically come minus once we are finding dx, that I will explain when we are solving the questions. Another applications is that we have done it like force dot dx plus f1 dot dx plus f2 dot dx equal to 0. Some advanced problems might involve differentiating it so that we can find the velocities also. How? Uh, Not velocities. Yes, I will consider some pulley problems also. Like you must have done in JEE a lot of questions like this, where many pulleys are connected and these are then connected to a block like this. Right? The block. Then A1 and A2, A1 above. So now find the ratio between A1 and A2. For that, differentiate this equation. What will you get? F1 into, this is displacement, it's dv, dx by dt is dv, plus f2 dv, this is velocity. Then displace it for this, then differentiate it further, we get f1 dA plus f2 dA, small change in acceleration. So just if we get the relation in displacement, we can just find relation between velocities and acceleration also. But at the end of the day, you just have to reduce it down to zero only, right? Okay. Now just let's consider a question on this. I have questions. Yes. So this is the question. Yes. If the spring has stiffness K and an unstretched length L naught and the force P, when the mechanism is in position, neglect the weight of the members. Okay, so we have to find the force P. Okay, so first of all, uh, simple convention, X this direction, Y this direction. Let's consider this as Y. And if a force will be applied in this direction, in the positive X direction with P, the pulley will move like here, here, and here. A little bit towards the wall. So we got a little displacement dy. And here in P, we got the displacement dx. Simple. Any problem? I don't think there might be any confusion here. So we got the displacement dx and we got the displacement dy. Now a simple method to find dx and dy here should be that you consider originally, like you can say that this is d theta, right? D theta. So the one parameter that is changing for dy and dx both is d theta. So you can just change the parameters of x, change in x, and change in y to change in theta, so that we get an equation in d theta. And once we get an equation in d theta, it will be way easier. Let me explain this in the application. Wait. So initially, let's consider the figure. Initially, what all forces are there in this ball, for example? A normal mg spray. So members, we don't have to consider any weight. So no mg, no mg. So only normal, but it is not showing any displacement in this direction towards the normal. So normal into, uh, let's say, displacement in minus x direction, which is b0 only. So we don't need to even consider it. Then here we will have normals 1, 2, normal in x direction, let's consider ax and ay. But all again, no displacement of this and this. So we can, because of course even if we are considering virtually the objects are moving, this will not move because this is fixed, right? So we can't even virtually consider the movement of this point. So ax into displacement is 0. Basically, delta u is 0. So net work done is 0. Net work is f dot dr. So what we get basically from here is this force P times dx, and this force plus F spring times dy equals to 0. Now, what is F spring? It is given that the unstretched length of the spring is L naught. Unstretched, unstretched length is L naught. And we are considering y as the length, like after all the after this arrangement. So we are considering that the final arrangement is at the, like is at displacement y. They are at a displacement y minus L naught, because L naught was originally the length of the spring. So the final spring length, so the final spring force will be K times X, where X is the change in the length of the spring, Y minus L naught. Kx simple. So from this we get K Y minus L naught as the expression of the change in length of the spring into dy. K Y minus L naught to dy is the work done by spring, and work done, and P times dx is the work done by the force P. We don't know this, but what we know is P times dx plus K y minus L naught times dy is equals to 0. But again, dx, dy, how to find? Now, the thing that I told, reduce them to one parameter so that we get d theta both sides, and in the expression on the right hand side we already have a 0, so we can cancel d theta. How will we find it out? We have taken it y. So now we will apply simple trigonometry. This is y by 2 considering symmetry, and this is theta. So this length, uh, this is 90 sine theta tan, wait, tan theta equals to this length L is y by 2. We get L equal to y by 2 tan theta. P, so we got L. So we got this length. X, we got X as y by 2 tan theta. But we want dx. How to get it? Just differentiate the above expression. Y by 2 tan theta is sec square theta d theta. Instead of taking this as y, we should take the given parameters. L is given. So just take L here. Instead of y, take L, because I just ignored the fact that L was given already. So what is the value of y here? The value of y basically is L cos theta. So you can just put here as, no, not here, here in this trigonometry, y by 2 is L by 2. L cos theta by 2. Yes. So we get, and simple, this is, this x length is L sine theta. So differentiate this only. Why differentiate L cos theta, right? So dx is L cos theta d theta. And we have y as 2L sin theta, differentiating y, 2L cos theta d theta. We have 2L cos, which is minus sin theta d theta, dy and dx. Just put it in the expression that we have made. P dot dx. What was dx? L cos theta d theta. K. What is phi? L sin theta. 2L sin theta minus L naught into dy. dy is minus 2L sin theta d theta. Equals to 0. The data cancel as we told. The good point of taking L was that both L are getting cancelled, because one mistake here was that we were differentiating x, so we also have to differentiate y here. So plus tan theta by 2 into dy. So automatically we would end up getting here only. Reducing the variables was our main concern, so we reduced the variables here, and p cos theta plus, sorry, minus 2k sin theta into 2L sin theta minus L naught equals to 0. We get P is equals to 2k tan theta 2L sin theta minus L naught. I hope this is the answer. 2k tan theta 2L cos theta minus L naught points. Yes. So this is the correct approach of solving the question. You could have taken another approach, but I guess this would be the fastest approach. Another problem that I was talking about, like I have another question, you can take it as a homework. Answer is also given, and theta expression in terms of tan is also given. No, I guess it's for the other question. Don't consider this. This is the answer. Okay. A hint here, same, is that find originally how far is this thing, then displace it a little further. Consider that the force has moved this point a little bit ahead. This is the little bit complex question, so I might make a solution video for this ahead, but you try it on your own first. Okay. uh, a little bit displacement will be here, which will be dx1. Another force here acting is kx. Now, the spring is in between these two members. So we know that this member, ahead one, is moving ahead, has been moved, displaced by dx1. So this will be moved by dx1. But then this spring force will act a force in this direction. And for this end will act a force in this direction. So there will be another displacement. Here we cannot consider dx1, we will consider dx2, and here dx3. Here also we can't consider dx1, because a spring force is also applying a force here. So which is stopping it this point to displace completely towards uh, whatever we have considered the virtual displacement. So there will be dx1, dx2, dx3. Find all in terms of L sine theta. For example, this length is x1, this length is x2, and this complete length is x3. So just find the expression for x1 in terms of L and theta, which is basically x1 equals to L sine theta. X2 is basically L2, well, right? 3L. 3L sine theta. And X3 is 1, 2, 3, 4, 5, 6, 7, 8. 8L sine theta. Just check the calculation and stuff here. And just differentiate all these terms, dx1, dx2, dx3, and put the expression of net force delta U equal to 0, net work done is equals to 0. uh, Kx, apply this equation here and try to get this answer. I am not solving the complete, I have already told a lot of hints here, but after telling this much hints you should be able to solve this question. So, and tell me in the comments if you are able to solve the question. Okay. Another approach for the virtual work method that I want to share is the pulley problem. Uh, I hope a lot of you must have studied this, but if you have not studied this, then this is a must for JEE because this helps in a lot of question. Like either you must have studied this concept or you must have studied the concept of like the length of the string is constant. I am sure that one of the concept must have been taught to you if you are studying from this lecture. Like the question come either the concept is of virtual work where you consider that summation t dot x equal to 0 summation t dot v equal to 0 summation t dot a equal to 0 to find the relation between velocities, displacement or acceleration. Or you must have considered the concept of rigid body where you consider the length of the string will not bend. Simple. So here, if this is of mass 3m, this is of mass m. Simple question. By virtual work, what we can consider, of course, this will move downwards. Acceleration, let's consider a1. This, let's say a2. In JEE, they might give you m3m. Like this question will not directly come, but a similar question might come. Uh, Even though that will be too simple. But let's go on a safer side. So this will move downwards. Now the question will come, find the relation between A1 and A2. How will you find it? This is T, T, tension. Same. The concept is basically tension in a string will be same throughout until like force is applied to T. So net tension 40 into A1. Here 4t is in upper direction, a1 is downward direction, so we'll apply minus sign. Of course, cos when it is -1. This is basics plus t a2 equals to 0. So simply tt cancel, a2 equals to 4a1. Simple. Okay. This concept you should know. And okay, this is enough.